All right, so we have been talking about the instrument, what the Thermo Fisher Scientific EXTREVA ASE could offer for the analysis of, organic pollutants in general. We have talked about EPA 1633A method that Ed just explained to us is a very manual method. So, Gopal, key question for you. How does EXTREVA ASE system aligns with the EPA 1633 method? Because, we heard, right, it's manual, this is automated, are we compliant?
I mean, in PFAS testing world, EPA 1633 is a huge step in terms of, it's a very standardized method, like Ed said, right? So, and you need standardized method to compare data to data. Without standardized method, you cannot do that. So in that regard, EPA 1633 is a huge step. At Thermo Fisher Scientific, we spent almost a year to make sure our EXTREVA ASE is aligned with EPA 1633A.
Right.
Having said that, if you look at 1633A as it is, it has a lot of manual steps. You do the extraction manually, you do your evaporation manually, you do your cleanup manually. With EXTREVA ASE, all we are trying to do is keeping the chemistry same of EPA 1633A.
Right.
We are bringing automation.
Right.
And we are streamlining a lot of those manual steps.
Let me stop you here for a second. When you talk about the chemistry, are we talking about the chemistry of the extraction solvents?
Yes. So we are keeping the extraction solvent same. We are keeping all the solvent required to during your SPE steps. We are keeping everything same.
Right.
We are using the cartridges is recommended.
Yeah.
So we are keeping the chemistry same. We are just bringing the automation, and we are just streamlining the whole EPA method basically.
Wow. And with EXTREVA ASE, do you need to go through the process of evaporation, or is this something that?
Yeah, that's a good question. So if you look at EPA 1633A, you will see that after the extraction, you basically dilute it and then evaporate down, and then you dilute again. So with EXTREVA ASE, what we are doing is, after the extraction, we are just diluting it to match the organic content below 20%.
Yes.
And then you can go directly to SPE phase.
Right.
And so by doing that,
yeah,
what you are doing is basically eliminating the evaporation totally.
Right.
And that way you can reduce your turnaround time significantly.
Which is my understanding exactly. For many workflows, regardless of the target analyte, evaporation usually it's very prone to error, number one.
Yeah.
Number two, not that EXTREVA cannot do it, of course.
Right.
We typically use it for other type of compounds, but in this particular scenario, you demonstrate it's not needed, right?
You don't need it, yeah,
Correct.
basically. And you, like you said, by doing that, you're reducing the sample handling.
Yeah.
And when you reduce the sample handling, you are basically reducing the risk of contamination also.
So you talk about the evaporation, right? So how this, tip drastically reduces time. But so how does the 1633 method perform on the EXTREVA ASE compares to the manual method in terms of labor?
Oh, that's a good question. If you look at the 1633 as it is, it takes about 12 hours of manual labor.
How many?
For, I will say, 16 samples.
12 hours.
Yeah, because especially for, I'm talking about just soil, sediment, and biosolid, not even talking about fish tissue.
Right.
Because for fish tissue, the
or
extraction time.
Animal tissue in general.
Sorry?
Animal tissues.
Yeah, animal tissue in general. That takes a long time.
Right.
With EXTREVA ASE, you can bring your manual labor almost 70%. Because
70%.
70%, because it's all automated. You're doing the extraction automatically. There is no evaporation.
Right.
And then you can do your cleanup through SPE semi-automatically.
So we are expecting at least 70% reduction
in manual labor. Yeah.
And what about the turnaround time?
In terms of turnaround time, I'll say it's about 30% less.
So with that in mind, we're talking about like something that is very important, I guess, for contract labs, for instance, right? Yeah. They care a lot about return of investment and how much money they can, make when analyzing a given sample. But what about, you mentioned this before, right? Like in terms of some others, manufacturers of instruments make claims about compliance. But how is it to get a compliance for the instrument? Like you mentioned a year working on doing a thorough testing.
Yeah. So
can you walk us through that one?
Yeah, of course. For us, it's very important that we validate our EXTREVA ASE in a very robust way.
Right.
So to start with, what we did is internally to look at our instrument to make sure the sensitivity wise is good, our LCM SMS. From there, we basically look at our EXTREVA ASE to make sure there is no PFAS contamination, background contamination. And from there, we started collaborating with EPA.
Right.
Actually, we developed our study plan.
Right.
Along the way, they advised us to develop our study plan.
Right.
And once we have a solid study plan, we basically started doing analyzing the samples.
Right.
The samples sent by EPA or EPA collaborators.
Correct.
We had soil samples, we had biosolid samples, we had tissue samples.
Right.
On top of that, we also have SRMs.
Which are certified,
certified reference material from NIST, mainly from NIST.
Okay.
So what we did was we compare side by side.
Correct.
So we ran those samples through EPA 1633A.
As prescribed.
As prescribed.
Right.
And then we analyze through our EXTREVA ASE based method.
Right.
Automated basically version of it.
Correct.
And we look at side by side data, we compare, we saw excellent similarities in data.
Perfect.
Basically, there is no significant difference in those two data sets.
Right, and we're gonna dig into a few more details on, the analytical values and validation process. Thank you very much, Paul.